Two more fast ones. Uh, this one says, first at the top, find the sum over j1 plus j2 plus j3 plus j4 is equal to 3. So it's got four indices added together to get 3. And inside the sum has 3 factorial over j1 factorial, j2 factorial, j3 factorial, j4 factorial. So it is definitely a multinomial theorem, and the size of multi here is 4, and the number which is both on top here and is added up to is the 3. So that's our power. And then we see that there are no multiplied on powers. So that means that they must all be 1. So when you were expecting to see 4 different powers, 4 different numbers to a j1, j2, j3, and j4, and you see fewer, you know that the ones that are missing must be a 1, because 1 to anything is 1. So that means that this is equal to 1 plus 1 plus 1 plus 1 to the 3. So 4 cubed, or 64. So where did all those 1 comes from again? That's because secretly, right here, are all 1s, since it needed some sort of number to a power. The only thing that you don't have to show is a 1. Alright, so now we're going to find the coefficient of x cubed y to the 7 in x plus y plus z minus 1 to the 5. Okay, now there's several ways to answer this one. Let's see. First of all, what do these powers need to add up to? Well, whatever it is, there could be some other missing powers as well, but it certainly can't add up to more than 5. 5 is the power on the multinomial, so the powers on the terms in the expansion of it can't be any more than 5. Just think about writing x plus y plus z minus 1 5 times in a row. Then the terms are found by picking one of each of the parenthesized pieces. And so, for instance, you could pick x from all of them and get x to the 5. Or you could pick x from 3 of them and y from the other 2, but then that would be x cubed y squared. So you certainly can't get x cubed y to the 7. In fact, there's no way to get y to the 7 anyhow, even no matter what the x cubed is. So, for multiple reasons, therefore, we'll say it this way, since 3 plus 7 equals 10 is definitely larger than 5, this term, x cubed y to the 7, can't exist in the expansion. So the answer to the problem is that the coefficient is 0. That's the way that you make sure that a term doesn't exist in an expansion, you just make sure that the coefficient is 0.